Hello, how you doing? Have you heard the term embedding model and you're not quite sure you know exactly what this is? Well, if so, then watch along with me for the next few minutes and I will quickly get you up to speed. Okay, let's get started. So what is an embedding model? Well, an embedding model is a neural network model that transforms complex data, like text, images, or audio, into a series of numbers called a vector. This is a dense numerical vector, also known as an embedding. The term dense implies most numerical entries in the vector contain meaningful numbers, i.e. no zeros. This vector captures the semantic meaning and relationships within the data, allowing machines to process and compare it based on meaning rather than just keywords. This makes tasks like semantic search, content recommendation, and classification possible. So how does it work? Well, using text data, for example, the model takes in the input text king and outputs a vector. The visual example I'm showing you here is a 3 dimensions and makes it easier to understand, but these vectors normally have dimensionality in the hundreds or thousands. So don't feel bad if you can't visualize these higher order vectors, as it's not very easy for most of us. Text words like queen or royalty will land nearby in the vector space, while a word like carrot will end up far away. This is how LLMs understand that Paris relates to France the same way Tokyo relates to Japan. So where are embedding models used? Well, these embeddings power semantic search use cases, recommendation systems, clustering, as well as RAG pipelines and LLM-driven systems. So how are embedding models different from LLMs? Well, to start, the purpose of an LLM is to generate and understand language. Alternatively, an embedding model's purpose is to take in text and generate a numerical representation. So what is the output of an LLM? Well, the output of an LLM is text, while the output of an embedding model is a vector. What about usage? LLM use cases include chat, reasoning, and content generation. Alternatively, embedding use cases include similarity search and retrieval. Lastly, LLMs are trained to predict the next word or token, while embedding models are trained to capture semantic relationships. To summarize the differences between an LLM and an embedding model, you can think of an LLM as a writer, analyst, and reasoning engine, while you can think of an embedding model as a meaning encoder that turns text, images, and audio into numbers so machines can easily compare them. Okay, so let me know what you think of embedding models. Feel free to share your thoughts in the comments below. I want to hear what you think about this topic. Okay, thanks for watching. This video, along with all the other videos in this place, are listed in the YouTube description. I invite you to watch other videos on my channel. If you like the way I'm sharing this content, please consider subscribing. When you subscribe, this really helps my channel grow. One last thing, we all love technology, and we're all excited about all the innovation with the cloud and machine learning AI. But don't forget to carve out some time to live in the real world. Go outside, go swim, go hike, go climbing, go surfing. Get out and move your body. And if you do, let me know in the comments. I want to hear about this as well. And with that, have a great day. Thanks.